Well, let's see, Autumn, it's actually time we should be starting. So would you like to do a roll call for us, and any other introductions that we need to make?
Sure. Joe Connell. Joe Connell, are you present?
Yes.
Mike Crump.
Yes.
Jeff Davids. Todd Green.
Present.
Kyle Morgado. Richard Price.
Here.
Debbie Spangler.
Here.
We have a quorum.
Okay, very good, thank you. Do any of you folks in the department know of any other introductions that need to be made that I'm not aware of? Otherwise, I guess we all know who's here, is that right?
I have pulled over Nick, and he is from Environmental Health.
Okay, very good. For Nick's benefit, do we need to go through our members and let him know who we are, or will that become self-evident as time goes on?
Yeah, we have 7 attendees also, so maybe if you just go around quickly and introduce yourselves, that might be good.
Okay. All right. I'm Joe Connell, Chair of the Technical Advisory Committee to the Butte County Water Commission. I am an emeritus farm advisor from UC Cooperative Extension.
I'm Richard Price. I've been on the committee for a long time. I am the retired agriculture commissioner for Butte County.
Yeah, I'm Mike Crump. I'm on the TAC also, and I was Butte County Public Works Director, retired about 6 years ago.
I can go. I'm Todd Green, Professor Chair at CSU Chico of the Department of Earth and Environmental Sciences, and a member for a few years now.
I'm Debbie Spangler. I'm a senior engineering geologist with the California Department of Water Resources out of Red Bluff, and I won't talk about how long I've been on the TAC. I'm not doing that math.
Should we just have staff go around to Christina, since there's some attendees?
Sure.
I'll go first. I'm Cami Loser, Director of Water and Resource Conservation for Butte County.
And I'm Christina Buck, Assistant Director with the department.
And I'm Kelly Peterson, Water Resources Scientist with the department.
My name's Autumn Thomas, and I am the Administrative Analyst for the department.
And Nick?
Yeah, hi everyone. This is Nick Ostrowski with Butte County Public Health and Environmental Health Division. I'm the program manager for the land use program here.
Okay. Very good. And we have some members of the public here as well, I take it.
There are 7 attendees.
Okay, well, welcome to all of you. And we hope this is a meeting that you will enjoy attending. The second item on our agenda is the authorization to utilize alternative standards for telecommunication. And Christina, you're gonna take that on, I guess, or at least mention it.
Yeah, so this is just authorizes us to continue to have these meetings remotely due to the COVID emergency. So If you pass this resolution, then the meeting can continue.
Okay, very good. So to do that, I need a motion to pass the resolution to utilize the telecommunications method and a second for that.
So
So
moved.
moved. Oh, that was perfectly synced, huh?
Okay, what I heard was Richard Price moved it and Debbie Spangler, I believe you seconded it. Does that sound right?
That works for me.
Me too.
Okay, very good. Thank you very much. So with that, I will get you the signed copy of that resolution later, Christina, and you can do what you need to do with that. So
Wait.
Joe, can we have
Yes.
a vote on that?
Vote.
Oh, excuse me. Sorry about that. Yeah, all those in favor of the motion, please indicate by what? Saying
Aye.
yes?
Yes.
Aye.
Aye.
Yes. Yeah.
Yes.
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 Any objections? Anybody? That sounds easier. I think we all approve it unless somebody objects. Okay. Hearing no objections, we will carry on with the approval of that motion. It sounds like it is unanimous. We'll make that recording. And now we'll move on to the approval of our minutes from our May 17th meeting. In looking through the minutes, they're very simple. Let's just take a moment to look over those to make sure that everybody's had a chance to look at them.
Joe, I read the minutes and I make a motion to approve the minutes.
Okay, do I have a second for that?
Second.
All right, thank you. The motion to approve the minutes has been made and seconded. All those in favor of accepting the minutes, please indicate by saying aye.
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 Anyone opposed or have any concerns or want to bring anything up? Okay, very good. Hearing none, we will move on. So the next, yes,
You might want to just call for public comment on each item as well. So
on,
before you move on.
oh, I see.
So for the
On-
minutes.
Oh, on the minutes? All right.
Sure.
So does anyone from the public have any questions about the minutes?
Doesn't look like it. So they can raise their hand and then we'll ask them to unmute, and there are not any hands raised.
Okay, thank you. Yeah, sorry for the Zoom meeting. It's always a little bit awkward, but we'll do the best we can here to make sure that everyone who is attending is not overlooked. So thank you folks for being here. All right, with that in mind, that brings us to item number 4 on our agenda, which is a discussion and direction regarding the groundwater quality monitoring that I believe, Kelly, you're going to be covering with us.
I am, yes. Thank you, Chair Connell. This is Kelly Peterson, water resource scientist with Butte County Department of Water and Resource Conservation. And yeah, before you, I put a few little slides together here to kind of help us talk through some of the items here today. But we are coming up into a new realm with water quality monitoring now that our GSPs have been submitted to DWR. And so it's a good time to kind of look at that alignment with the new Sigma regulations. So I'll just go ahead and jump into it here. Let's see if this is advancing. Okay, so today I'm going to spend a little bit of time just reviewing the high level components of a 2022 monitoring program and sort of compare that to our previous efforts, which, as you recall, was done through what was called the Basin Management Objective Program. And this TAC helped put together many of the parameters for that, which included both groundwater level monitoring and groundwater quality monitoring. But today we're just going to be focused on the water quality side of it. So then I'll bring up a few key points and questions, sort of a game plan, if you will, that we can look at and talk about, and then hopefully I can get some feedback from the technical advisory committee here today to help develop sort of the monitoring protocols and the field manual that I'll be working on between now and August, and hoping to bring that back to you guys for review at the August meeting right before the monitoring actually occurs. So today's sort of a get in there, look at some of the bookends, see if there's any feedback from you guys, and that way I can incorporate it into more of a written document that we can spend a little bit more time reviewing at the August meeting. So just to do a quick comparison, the Butte County Groundwater Quality Monitoring Program here on the left is some bullet points of our previous program. And if you recall, this was for compliance with Chapter 33A, which is part of the Butte County County Code, and there's an ordinance for groundwater conservation. Chapter 33 still exists, which does include information about a groundwater level monitoring program. However, the groundwater quality program was really detailed in Chapter 33A, which has sunsetted with the transition of the program to a more SGMA relevant program, which we've been talking about for quite some time. And so it's a good time to recircle back on that. So in the past, for about the last 20 years or so, we've had annual monitoring of groundwater quality at what are called sub-inventory units. And that was really related to the water inventory and analysis, but it was a way to, chunk out portions of the county locationally so that we could have a better understanding of conditions in those areas. As always, this groundwater quality monitoring program has always been focused on salinity, and it's really focused on degraded water quality caused by groundwater pumping. So a lot of times when we talk about groundwater quality, we think about all sorts of other things, all sorts of other parameters, nitrates, arsenic, et cetera, and there are other agencies and other programs in place that actually do a really good job of monitoring those. And so that's, that is in their court, and we are looking at salinity, mostly focused on an agricultural focus as well for water quality. But we look at salinity through what's called electrical conductivity. And we've been tracking that. We've been tracking pH and temperature, and we try to do that at the peak of the irrigation season. And so that's generally in July or August. And so that program covered 13 sites throughout the county. And I'll pull a map up of the difference between these two also. And we've got about 20 years of data per site, give or take. There's a couple that we had to, or one at least that we had to move in the middle of it, but there's a good data set there. So now moving into 2022, we've got our GSPs in place for all 3 subbasins in the county, and they have outlined a groundwater quality monitoring program that is in compliance with SGMA. And so it's also lining out once a year water quality monitoring at what are called representative monitoring sites. And that's also done for salinity via electrical conductivity at peak irrigation, so in August. The number of sites is about double or so. There's 24 sites now throughout the entire county. Actually, one's in Glenn County as well. And most of these sites do not have much data associated with them since they are relatively new with the GSPs. There has been some work done on a few of the sites, and I'm in the process of lining that up. And I'd like to go back and data mine to kind of fill in some of the missing pieces and see historic information on that. But that'll be a future effort. So it kind of lines up where we're at least with where we were, and now where we are with the SGMA compliance type of groundwater quality monitoring. So just looking at some of the numbers too, we've talked about what we've measured, and as far as electrical conductivity, Previously, there were, you could call them thresholds, but goals in mind, or objectives, basic management objectives of having under 900 microsiemens per centimeter for drinking water and under 700 microsiemens per centimeter for agricultural water. And these are really based on the EPA's maximum contaminant levels, the secondary ones. And so those really are not health oriented, but they're much below that. So secondary contaminants levels really deal with things more like the odor of the water, the aesthetics, things like that, versus a health concern. So currently in the GSPs, what is identified is in the Vina and Wyandotte Creek subbasins, what's defined as an undesirable result is if 2 of the wells in either of those subbasins, and this is for each subbasin. So 2 wells in the Vina subbasin reach their minimum threshold for 2 consecutive dry years in a row. That would be considered an undesirable result. And likewise for Wyandotte Creek. They both also have the same measurable objectives. And so what they're saying is that, okay, we want to be at no higher than 900 microsiemens per centimeter. Of course, we would like to be lower, but the minimum threshold is a higher contaminant level of that of 1600. So it's a little counterintuitive if you think about it, because we've been talking about minimum thresholds with groundwater levels as being low. So in this case, it's a concentration, and so you have to think about it as a higher level. In Butte, they've identified a different undesirable result. And so in that subbasin, they say that if 25% of the wells reach the minimum threshold for 2 years in a row, at these following measurable objectives of 700 or a minimum threshold of 900 microsiemens per centimeter, that would trigger an undesirable result, or the measured historical high, and whichever number of those is greater. So these are sort of the details of the parameters of what we'll be measuring. And we can do that with the equipment that we have. Those numbers have been already established by the organizing groups that have spent years discussing it. So this is kind of already set in stone. This isn't really a something that we're looking at changing or anything at this moment, but it just sort of sets the stage of the program itself. Sorry. Go back one here. And so this is a map to give you an idea of generally where those locations are. So the black triangles that you'll see here, these are the new Sigma related water quality monitoring sites at those representative monitoring sites, the RMS wells, and those are indicated in the GSPs. The green diamonds are those that were previously measured by staff for the past 20 years for the BMO program. And then the pink line here indicates the different subbasins, with Vina being to the north, the Butte subbasin being directly to the south of Vina, and then over on the east, the smaller subbasin being Wyandotte Creek. And one thing in here, there's about 8, well, there are 8 groundwater quality sites per subbasin.
Kelly, I have a question.
Yes.
Those previous previous sites, they're no longer being monitored, the green?
Well, that's a good question. So that's actually one of the things we're talking about today. So they were monitored last year, and now that we're shifting over to the Sigma and the GSP monitoring, that is one of the things of discussion today. So that would be, I'll pull it up in a slide later on, but it's something that we can all talk about.
Okay, thanks.
Mm-hmm.
I have a question too.
Sure.
Why was, and maybe this isn't the right group for this, but why was temperature and pH dropped? Is that being covered by somebody else, or is that no longer considered important?
So it wasn't necessarily dropped. The basin management objective program covered those 3 things. And so now that we're moving into the Sigma program, that's what we're here to discuss today. So it'll be sort of one of those things that we can all talk about of whether or not it makes sense to continue to do that or not at these sites.
I don't understand. So you're saying they're not dropped, but so does that mean we can discuss whether we can include them?
Yeah.
Oh,
Exactly.
okay. I didn't know that. I thought
Yep.
it was all, and what about the MTs? It didn't sound like those are discussable or that we can discuss those because the Vina MTs for the water quality are pretty high, but those are off topic, or is that on topic?
Those are more established in the GSPs, I would say, Todd. And so there's this lineup of, there's groundwater quality monitoring that needs to occur on the GSA level. The county is actually doing that monitoring itself. So because of the fact that we've done some of this stuff before, we've done the pH, we've done the temperature, we've done the EC, now we're going to new sites, and we're here today to talk to the TAC about what that looks like in terms of what we monitor, where we monitor, how we do it, and get some feedback on that. Those levels, however, those were already established by the GSAs. And so I would say we have to, at minimum, meet what's required in the GSPs, but as a recommendation from the TAC members, if we wanted to discuss, additionally looking at temperature and pH, that's what we're talking about today.
Okay, thank you.
Sure thing. So, so looking at these, there's a pretty good distribution, I would say, throughout all three of the subbasins for the new black or gray diamonds that you can see of the RMS sites. Certainly a lot more in Wyandotte Creek than we've had before, especially in the southern part of the county. Certainly a lot more in the Butte subbasin as well, and just a different arrangement in Vina. And so what we've done is we reached out to the folks at DWR because they also have a groundwater quality monitoring program, and some folks that Debbie put us in touch with, and kind of pick their brain a little bit on how they do groundwater quality monitoring in these observation wells when they do their work. So one of the big differences here is that these green diamonds that you see, these are domestic wells, they're irrigation wells, they are municipal wells, they all have pumps in them. And so the idea is that when we went out, we would coordinate with the landowners, purge the pump, get a sample. Once we feel like the water has been flushed, et cetera, et cetera. This new set of wells is really looking at observation wells, or those dedicated monitoring wells, most of which on the map here are those observation wells. So all of the black diamonds in Vina and Butte are those observation wells. 3 out of the 5 in Wyandotte Creek are, 3 out of 8 in Wyandotte Creek are, and then 5 kind of have that old, have a pump on them kind of procedure. So what we did is we purchased a new piece of equipment that has 1,000-foot tape on it. It's an electrical conductivity sensor that you can get measurements basically, all the way down to 1,000 feet. So I think it'll be a lot better in that sense of getting a good representative sample. But one of the things we talked to them about was, okay, well, we got to look at the screen perforations, which is basically where the screen is in the well that's letting the water into the well casing, and where in that column of water do you take your measurement to get good measurements. So I'll bring up this next map, which kind of has a zoom in on the Vina area. And as I said before, these are all observation wells, the dedicated monitoring wells that don't have pumps in them. It's a standing column of water. And so what DWR staff does, which we think is a good idea as well, is looking at each one of these and saying, okay, of the top, the first perforation that we get to. So if we're looking, say the second well here, the 28 M002, sorry about that, 23 north, 01 west, sorry about that. 28 MOO2. You can see the total well depth is 1,044 feet. The top perforation starts at 791 feet down from the ground surface. And the very bottom of that perforation is at 1,021. But in between there, we've got some portions that are screened separately. So when you first get to the first screen, it goes from 791 feet down another 10 feet, and that would be the 801. And so the idea here is that we would be looking at the midpoint of the first perforation. So basically taking, the difference between the 791 and the 801, cutting that in half and saying, okay, we're going to take, our measurement now at 796 feet down below the ground surface, so that you're not introducing other waters down into deeper parts of the casing. And so it's really just to, prevent that. I wouldn't want to call it contamination, but the mixing of water, so to speak. And so that would be what we're looking at for all of these. So for example, the first one, 23 North 01 West 03 H002M with a well depth of 553 feet. This one only has one screening interval. It happens to be 30 feet long of screening from 510 feet down to 540 feet down. And so the idea is that you would take the halfway point, which would be 525 feet, and get the measurement there. So I wanted to open up to the TAC members and make sure that part of it's kind of clear, or if there's any questions on that.
I think you have a question from Mike Crump. He had his hand up for a while.
Oh, okay, good.
Oh.
I'm sorry, I'm not looking at the participant screen.
That actually was my previous question, but I do have one. Can you tell us the rationale for not pumping the water? I mean, it's kind of we'll use the word stagnant, and I'm sure it isn't under there, but it's not really a moving, working well. Does that impact the water quality one way or the other?
Yeah, that's a good point, Mike. I would say that, for looking at the purposes of this program, there is really what we're looking on is the degraded water quality caused by pumping. And so there's potential with overpumping for movement of brackish water from that freshwater pool, in the deeper portions of our aquifer, where the groundwater is then pumped from. So if we can get a sense of what are the conditions in that standing water without the mixing, I think that gives us a better idea of the conditions before it's pumped up to potentially impact the beneficial users that are pumping that water out. Does that make sense?
Yep.
Okay.
Can I just add in here too?
Sure.
Yeah, I mean,
Anytime.
the idea is too that water, in these screened intervals, water that's in the aquifer is moving through the well. And so if you put your probe in that zone of the well, then you actually are able to measure the conditions in the aquifer water at that depth.
Good point. Yep.
I had a question.
Yes.
Yeah, we're talking about the EC measurement for salinity, correct?
Correct.
Primarily.
Yes.
Yeah. Well, on the H002M well, that's would be sampled near the bottom of the well, which is a good thing. On the MO02M well, however, if you are sampling at the top perforation, we would expect, I think, that salinity would be intruding from the deeper levels. So, if you had a deep well like that, it would seem to me that it might be better to sample it deeper in the well. I don't know. I mean, that's an opportunity to see if it's moving up from that saline layer that's down there around 1,000 feet or wherever it's at. It's down in there somewhere. So
I think they are doing that, though. They are sampling all the way down.
Is that true? Or are you just sampling that top first perforation?
We are suggesting to sample the midway point of the top perforation only, so that it doesn't
That's-
actually move that water and mix it. And
Right.
that was after conversation with Debbie's team, and maybe you want to chime in on that too, Debbie.
That's what I thought you said,
Mhm.
and it
Yep.
seemed to me that, that if you're worried about keeping an eye on, on the first warning signs of salinity intrusion, you'd want to be sampling at those deeper levels. But I'd certainly like to hear what Todd and Debbie have to say about that.
No, I actually thought, I heard wrong. So you're right, Joe. I have the same concern, but go ahead, Debbie.
Sorry. I actually have to admit, I thought I heard the same thing. So I think it would be interesting to see. I know that that our water quality team samples that top one, but they're actually sampling. So they're actually removing water there. So they couldn't do it at the other zones at the same time. But if you're just dropping a probe down,
Mhm.
I wonder if you couldn't gently see if you saw a change going down, over time. Maybe do it. I don't know how often is this. I think it's an annual measurement, but I think it would be interesting to see if that water quality did grade through that depth, because it's kind of a wide. For some of them, that screen zone is pretty wide.
Yeah, that's a good point. And that's exactly what we're here today to hash through and figure out. So
I got another question. Another question. How difficult when you do these tests? Are they quick? Is it kind of just looking at a readout on a meter and writing it down, or do you take a sample and take it back to the lab, or what?
yeah, that's a good question. We don't bring any samples out of the well with this proposed. So we have this new piece of equipment that will allow us to get down to those areas. The idea is that well, there aren't any. So what DWR does is they have what's called a hydro sleeve, and they actually put a little. I'm not even sure how to explain it, but it's a bag basically that sits there for 24 hours or so overnight, stabilizes, and then when you trigger it, it captures the sample from just at that portion of the well and seals off. So that is a much, more concerted effort there. The equipment that we just bought is a meter, and it takes about 10 minutes or so to stabilize. So it would take, if it would basically just add on, I would say, depending on stabilization times, that much more if you were to do it per perforation. But that's definitely an option, depending on how the group feels.
Right. It seems like if it's that simple, more data might be beneficial.
Yeah. So in addition to that, I'm wondering what's going on with the Chico area. Is Cal Water going to provide any information? Because the only well I see is that J005M, and that's pretty deep, 700 feet below. But in terms of municipal water in Chico, are we going to get any information with that?
These are the RMS sites that have been identified in the GSP. So they're not, the Cal Water wells are not part of the current grid. No, not here. In Wyandotte Creek, there is one.
And they certainly sample their wells and report those out
That's
annually to consumers through their consumer confidence report. So, that data is available on a broader, just from a water quality perspective.
Okay, thanks.
Sure.
In this particular list of 8 wells, most of them are screened over a very narrow range, and then just one reading there makes sense. But in the 2 that are deep, just for time savings, I don't know that you'd need to take a reading at each one of those positions, but you might take one, near the top of the perforation, and then in the middle reading, and then maybe one near the bottom, something like that, just to give you an idea if there is any kind of a gradient.
Mm-hmm.
So Joe, are you talking about in particular the the 1,200 foot deep well?
Right. I was thinking, no, not that one so much. I was thinking about the M002M and also the C001M, where their
There's
screened
4.
intervals vary.
Mhm.
And so in those two wells, that would give you an opportunity to look to see if there was a gradient between the bottom of that well and the top of the the top of the first perforations.
So maybe something that, just to follow along your example, on the 18C001 well, you'd be suggesting taking one maybe at 775 feet down and then maybe one at 875 feet down, something like that.
Yeah, maybe, right, exactly. Maybe 775 and then maybe 875. I mean,
Okay.
just to get an idea if there's any difference between them. And since you have that depth, you might as well get a reading down near the bottom.
You guys have a max depth of 1,000 feet.
Correct.
Okay, yeah. So
You're still taking these samples in July or August during,
This will be the first year of this particular effort, and yes, it'll be August of this year.
we could also pull the geophysical data for these well installations and, and kind of take a look at that and see if anything jumps out that makes one of those, screen zones more interesting than another as well. Not just, a depth gradient, but
And can you talk about that a little bit more, Debbie? What would jump out to you to say, okay, this one we should, and this one, it's basically what they pulled up at the time they were drilling it, the substrate itself?
yeah, we could, it could be a myriad of things, but
Okay.
I would, oftentimes in the geophysical logs, you can see water quality changes on there. And we can also, we also have a water quality analysis done on some of them. And we can also take a look at the formational calls for those. And that can give us a clue as to what kind of water quality to expect there. So there might just be another layer of discussion. I don't think that I don't think there's anything invalid about, taking a reading at the top of one of these, wide screen zones and then, toward the bottom of them. I think that's a great idea. I just thought we might, have a little bit more context for the data that way.
Yeah, definitely.
So based on Debbie and maybe Christina's experience, then if you're sending the probe down one well, so there's nothing sealing anything off, is it a chance that there's 100% mixing going on and that you're not going to get reliable data, or is it better to go to multi-completion wells? Or I know you talked about stabilizing, but is that enough to really get a difference? Even because it's still one well, and in the water in that well, is it mixing, or do you actually get a difference?
That's a good question.
Yeah, I think that that probably is dependent on the aquifer conditions. And so, in some wells where you have a difference in water quality between the top of that wide screen and then in the bottom, and it's something that is, maybe density related or something like that you would see stratify.
Like pressure, I think pressure related too.
Pressure,
yeah, well, I was just thinking so constituent wise, if it was something that, if you didn't have a lot of flow, if it was something that you would see kind of stratify, like based on density or something like that, you could probably see a stratification there if there really was a difference. You're right. And I think that because a lot of these, and I'm going to jump out there and say that without actually looking at the data for these ones in the deep zones in the northern part of Mina, but definitely out in the Butte Basin, these deeper ones are highly confined. So I'm kind of thinking this is kind of an interesting experiment to see if it actually stratifies, because you've got a lot of pressure pushing a lot of water up that casing, which it's not really flowing, but it'll be interesting to see if it really shows anything at all.
Are we doing this in multi-completion wells at all, or any of these or no?
Yeah, so actually these are, a number of these are.
Okay, so it would be a
Yeah.
different well.
Yeah, these
okay.
are basically the multi-completion wells. They just also within, this is the deep well of a nested well, like 28M002. But
Right.
even as the deep well, it just has these different perforations.
Sure. Okay. Okay.
Yeah, a lot of times we do that where you have a wide area that's actually productive. And you might have like really thin layers of clay in between that aren't really laterally a confining layer that separates aquifer zones.
Right.
Or you might have a really wide area that is almost all productive, and to maintain the stability of the casing, instead of putting perforated casing for 200 feet, which is in PVC is pretty
Right.
pretty weak. It's this, the screen is split to the,
Right.
and we target the highest productive zones through that
Gotcha.
area.
Okay. Thanks.
But to your point, maybe since this is the first time using the probe and measuring these wells, maybe we actually try to take a measurement in the middle of each of these perforation zones and see if it's stratified at all or if it's all mixed, and then that might actually guide.
Future.
Yeah.
Yeah, that's what I was
Refinements.
thinking. Kind of fun.
Yeah.
Right.
Sorry, it's the
No,
kid
it's good.
scientist coming out of me, but
Exactly.
something better than doing paperwork.
Yes.
Like 2 weeks, 3 weeks in the field. Okay, let me just maybe move through the next couple of slides, and that'll kind of help frame up some of the questions, and then we can come back to this if we need to, if that sounds good to you guys. Okay. Believe this next slide is looking at some of those questions to frame up. Okay, so this originally was, some points to throw on a wall that we could talk about, or game plan for discussion, either keeping or changing. But one of those would be, do we want to monitor only at the RMS well locations in 2022? Looking at that map, we do have some other sites from our old BMO program. Some of those could be incorporated. We do have 24 sites already, but there is a good data set for some of the other ones as well. Some of those sites, however, we don't have WCRs on, well completion reports on. We don't know how deep they are. We don't have any perforation information. So it's not necessarily a one-to-one fit for all of those to be good. The other point would be, do we want to measure only electrical conductivity and temperature? The probe itself does both, so that's a real easy thing to do both. pH is a separate probe, and that would be actually, we'd have to gather the water. We'd have to somehow collect the water from these to be able to do that, which involves a whole nother process. Like I was explaining with DWR staff, they go out, they set them, they wait for them to calibrate for 24 hours, pull them up, and do a number of different measurements on that. Another point would be using the new equipment at the observation wells, measuring at a depth halfway between the top and bottom of the shallowest perforations. And so that's what we've been talking about now. Do we want to do that, or do we want to do every perforation halfway down, or a portion of those? And then we've got some other things to think about with measuring non-observation wells. And so those are the 5 in Wyandotte Creek that I discussed. So Wyandotte Creek, as you know, just got its first multi-completion well through the DWR Technical Support Services program last year that we applied for. And so there are 3 wells in one multi-completion well with 3 separate casings in there. But the other 5, one's Cal Water, a couple are private residences. And it's going to be a matter of trying to find those landowners as well, and asking for permission to be able to monitor between now and August also. One of the wells is actually not in our monitoring grid right now, but it did have some spikes, I think, in historically, which is why it was pulled in. by the consultant team in the GSPs. And so with that, then once we get that figured out, I'll go back and develop the monitoring protocol specific to that and a field manual, and hopefully get that in time for the TAC to review in August before doing the work. Looking at timing though, we might want to reconsider that given the number of sites, but we can talk about that. DWR basically refers to USGS standards for their monitoring protocols. And we could also look, of course, resources, the manual for the piece of equipment itself, reviewing other GSPs around us, and also the monitoring protocols in the GSPs currently are referring back to the old BMO program. So those will have to be updated eventually as well too. And then reporting. So in general, thinking about, reporting using the previous memo format, but plotting those values with the MOs and the MTs so that we can see where those sit in relation to what are in the GSPs for that. And going back and mining through some of the old reports from DWR and other resources eventually to add data to the graphs if they are available from other sources, so that we can kind of see, what our current measurements are in relation to any historic data that we can find. And then possibly revisiting the program again in the spring of next year for possible inclusion of other sites or parameters. So realizing that we may not be able to get everything we want done right now, that we do have that opportunity to come back and make it even better next year. So with that, I guess I will, yeah, that's it. I'll go ahead and open it up and we can talk about some of these things.
Hey, Kelly, have you guys given any consideration to testing some of the more shallow zones as well, and not just the deep ones? I mean, I know that the original concept behind that the trend monitoring was deep salinity, but with Great Valley sequence marine sediments that are pushed up on both sides of the valley. In portions of the valley, we see salinity issues in shallower zones in places, and especially I'm thinking in Wyandotte, that might be an interesting place for that.
Mm-hmm. Yeah, I would say Wyandotte Creek is actually limited in the number of wells that it has in general, and those I'm just going to pull that up real quick and take a look at it. I want to say off the top of my head that there aren't actually any, well, not any, but a lot of existing deep wells in that grid. So yeah, we've got a 120-foot depth, 120-foot deep well, a 320, a 656, and then the observation wells, those go down to 1,000. And then we've also got one that is an irrigation well at 190 feet deep. So Wyandotte Creek just doesn't have a lot of wells to begin with.
Oh no, but yeah, but you gotta you have a wide
Yeah.
variety, but we were looking at the deepest completions in the multi-completion wells on the list there.
Oh yes, for Vina. In Wyandotte Creek, we've got all three of those. Actually.
Oh, perfect. Okay.
Mm-hmm. So I would say Wyandotte Creek does have quite a range, actually.
Okay. Yeah. No, that's good. Okay.
Mm-hmm. And in Vina, we are looking at a range of about 520 to 1,200. So yeah, those are the deeper ones. But I would say that when those were chosen by the consultant team, they were targeting the deeper ones. So I don't know if you have anything to add there, Christina.
They were targeting the deeper ones in Wyandotte, sorry, or in Vina.
In Vina in general.
Yeah, in Vina, yeah, for sure. But
and
yeah, I think
would say in Butte too.
Yeah, that's right. And I think to your point, Debbie, having more variety in Wyandotte Creek, it's a more complicated story down there, and we're just beginning to know that we don't understand it. I guess we've known that, but yeah. trickier.
And we helped by providing the observation well information.
Exactly.
Yeah,
Yeah.
that added more to the why.
Exactly. Yeah. But yeah, I mean, we haven't seen any, shallow or in general any salinity issues in Vina or Butte. So that was kind of the consistent approach there, was to go deep.
Mhm.
That actually dovetails to the question I had was, going back to the, temperature or pH additions and even the shallow ones, is there anything from the BMO, the history during the BMO, that are certain areas been questionable, been like, oh, wow, we should really look at that. And then now we're switching to Sigma, and maybe that area is no longer on our list. And so basically going back to the old data, looking for questionable or problem areas and seeing maybe we should keep those on the list. Has that already been done, or is that something that we should do?
Yeah, I would say that when they were picking these sites, the history of data that we've provided through those memos was considered, and you'll see in the GSP they do talk about that. There are, I would not say there are any really problem areas because of the fact that we've always been well below, especially in Vina, with both, pH, temperature, and the electrical conductivity.
Yeah.
I want to say there was a couple of spikes in the M&T well, but that was a calibration issue, and that one's just tricky. We had to spend some time to get that to stabilize, but I do think that we still have, let me look back here, we still have some in the general area of that. Yeah, so this one here would be close to that. Yeah, I don't know if that answers your question, Todd.
Yeah, that helps. Thanks.
Okay, sure. And I'm happy to pull up some of the graphs from the last memo that we actually put out was 2020, but we can look at some of those today too, if interested.
And Kelly, I'm not sure when you would like to take questions from the audience, but we do have a hand raised.
Okay, I'll defer to you, Joe, if that's
Okay.
something that you'd like to do.
Well, certainly, if there's questions as we go along, I think this is the time to address them while the question is fresh in mind. I kind of had a question as far as doing this efficiently with all the wells that you've got to monitor, and you mentioned trying to look at previous levels and preparing some kind of a graph or something. I think since this is the first year of these new levels, I think you could really do this in a table format and just make it easy on yourself, since you don't really have anything that would lend itself to a graph yet. So I just, especially in this particular area, since this is not a parameter that we've had concerns about in the past. So I don't think I would overthink it unless you discover something really surprising.
Okay, that makes sense.
And if there's a question from those attending, please ask it.
Jim Brobeck.
Thank you. I assume that spikes in saline intrusion could be transitory and caused by high volume water extraction. Is monitoring being scheduled to coincide spatially and temporally with high demand operation of production wells that might create these temporary cones of ascension from the marine layers?
Yeah, I would say that if you look here, there's definitely spatial separation here across the subbasins, and the fact that we're looking at the data in August in the peak of the irrigation season. That's what we're aiming towards. I don't know. I think what your question is maybe, are there any high production wells near these? And that's not information that I've got, or that I don't even know if we could get that necessarily.
Do you?
But at this point, this was the grid that the consultants basically did an analysis and said, you know, we think that these existing, because these are existing observation wells, so these will be the most representative of the conditions that we want to monitor for, which would be, like you said, overutilization of groundwater pumping that pulls in those marine and brackish waters. And so, is that helpful?
Well, it is, but I'm not confident that it would be close enough to any cone of ascension, and I'm also not familiar with how long these cones of ascension persist in areas where they've been observed in other places in the state. Once it mixes with other aquifer water, it would of course dilute the reading. And it seems to me that if you want to reveal the problem early in its inception, that it would be a good idea to have a monitoring well close to a high production well to see if one of these cones of ascension are occurring, and before it creates a problem in the general aquifer. So I think it's important to try to do some monitoring near high production wells, because these cones of ascension aren't going to be, I doubt that they're miles wide, but again, I don't know. Maybe Dr. Green would have an idea on that, how large these cones of ascension are in other parts of the state where they have occurred. Something we definitely want to avoid. That's what this is all about.
Mm-hmm.
Thanks for taking my question and my comment. I appreciate it.
I don't have a clue how wide they would be. I'm thinking miles, but Debbie may have a better idea.
Sorry, I have 2 layers of mute and I only unmuted myself on one. So sorry, I don't actually know how wide that would be. And I'm sure it's very area specific and action specific, but and so I wouldn't have any prediction for what it would be here. But Kelly, I was going to ask, have you guys tried your meter in the multi-completion wells yet? My only thought was we have data loggers in those. And I was just curious how we needed to coordinate that.
Right. No, I have not. I have not done a dry run on these, or a wet run, so to speak. So yeah, we should talk about that a little bit more. Is it a physical potential plug issue? Like the probe won't get down past it? Yeah.
Yeah, that's okay. I mean, we can try it and see. I mean, the worst case scenario is we got to pull it all out, but it might be nice to maybe coordinate a test run day.
Yeah.
And just give it a try and see what it's like.
Okay.
Because if we do need to pull these data loggers, oh man, sorry, we're already doing that to do water quality all over the valley this year for drought monitoring. So like always do now, it feels like is running out to pull data loggers out and going back out to put them back in for sampling. But we need to do that in a decent amount of time in advance of you going out to take the measurements, because we'll stir up the water when we pull the data loggers out. So I don't know if you want this. Yeah, it would be easier. Ideally, we would just leave them in, but I'm not exactly sure. I don't know how big your probe is. I don't know how likely it is that we can get it past the data logger. And
it's just like a sounder.
Yeah.
Okay, that might not be too bad then.
Mm-hmm.
That's what I was thinking. Sounder down alongside it, right?
We do, but rarely do you go down to below the data logger. So you guys would probably go below the data logger in most of the wells and have to come back up past it.
Yes.
But if it's not very big, then it's probably not a big deal. And we'll just, on a rare occasion, it may get wrapped around them, and we'll, we can always just pull everything out to untangle it. It's not like getting it caught in something that's permanent in the well. So,
right.
But if you want us to plan a day where, we come
try it out. Yeah.
Try it out. Yeah.
We can
do that.
That'd be great.
But another thought too, Debbie, is that, well, 2 questions. One, do you have kind of a spreadsheet of how in each of these wells, how what the cable is, how deep the data logger is.
Okay, so do we know what that is? Yes. Do we have a spreadsheet of that all together now?
Okay, well, okay, you have it somewhere.
Not
Okay.
yet.
We do, yeah, we have a ballpark idea, yeah, of how deep all those are, but
Because that's the other thing. I mean, at the most, they're usually like 200 feet, right? And in these ones, they might be only 50 or something. So even if Kelly had to pull that out first, she's going way deeper than that.
yes, that's
So it may
true.
not
You're
make-
right, yeah. So we would be, in most of these cases, except for where you're talking in Wyandotte. But in most
Yeah.
of these cases, I would say you're, several hundred feet above that to pull it out.
Yeah.
But yeah, I don't know. That's another experiment to see if it makes a difference or not.
line that
Yeah.
up.
Okay, that's a good
Mhm.
point. Yep.
We have another hand raised in the audience. Jeanette?
Yeah, my question is actually a question comment. A lot of the observation wells are fairly deep compared to domestic wells. And since I have a domestic well and I know most of my neighbors' wells are not nearly deep as a lot of these. So just kind of curious what kind of monitoring is going on regarding more shallow domestic wells.
Yeah, that's a good question. So shallow domestic wells, we do a lot of monitoring for groundwater levels throughout the subbasins, and that gives you an idea of how far down it'll take to get to your water. Water quality wise, this program is more focused on the salinity, and so the idea being that there are saline waters in the bottom portions of the aquifer that we're concerned about maybe getting pulled up to the shallow areas with use. And so that's why we are focused on those deep areas as opposed to the shallow areas. However, as far as other water quality parameters go that you might be concerned about, like nitrates, et cetera, those are covered by other programs, and I'm happy to get you in touch with some websites where you can find water quality in your neighborhood through those other programs and other agencies. I don't know if anyone has anything to add to that.
Yeah, I had a question again, thinking about Jim Brobeck's question, and that is, or maybe it's a comment. I'd like to know what Todd, you think about it, and Debbie thinks about it. The shallow wells generally are maybe 150 feet, 200 feet, something like that. For the domestic wells, maybe even less in some cases. And the pumping wells, the large production wells for agriculture, tend to be more in the maybe 300 to 400 foot range, I think, somewhere in there. And please correct me if I'm wrong, but what we're concerned about is salinity that's actually down at that saline layer that is down somewhere around 900 to 1,000 feet, something like that. So if you have a large production well that that's pulling from that 300 or 400 foot range, it's pulling water in from the sides, mostly in that cone of depression, and not so much up, from that bottom 600 feet, right? So other than the Chico urban area where Cal Water is pumping from maybe 600 feet to make sure they get pure water below any shallow contamination, most of our production wells are being pulled from much higher in the aquifer. So the likelihood of sucking up that saline level from there, I think, is pretty slim. But maybe Todd, could you comment on that, or Debbie?
Sure. Yeah, I'd say it's important to monitor when you're got those high production wells, and I mean, that's those cone of ascension. It's very possible for it to affect it. Now, what is the actual, what is that critical separation between where the pump is and where the saline water boundary is? At 1,000 feet? Is it 500 feet before it doesn't make any difference? I don't know what that is, but I still think it's worth monitoring and considering, because it can, and especially as Debbie said, once you get to the east and you start bringing up the depth of the Great Valley sequence in Ione, you can, even from the 200-foot level of production wells, I think you could create those cone of ascension. So I still think it's important to monitor.
Yeah. Okay, thank you, Todd.
And I would just add, these are multi-completion wells, and we do have, DWR has done a round of sampling on them at least once or more. So there are a couple data points already on these wells, and we haven't seen in any of that sampling, I don't believe, any high EC. So I think, you know, by sampling these wells more regularly on an annual basis for EC, will really create a baseline that will be valuable going forward.
And just to clarify on that too, I starting to do the crosswalk between the 2020 groundwater quality report from DWR and these sites, and some of them are in, but there's a few that aren't. Of course, none in Wyandotte Creek are included, that because there aren't any multi-completion wells, but there are 2, I believe, in the RMS network that are not in the, at least they weren't in the 2020 NRO one. So just a clarification on that. But yeah, good point.
Great, yeah, thanks, Kelly.
Yeah, no problem.
We should check our stable isotope recharge study too, and
Great idea,
Tuscan,
yeah.
and
Okay.
Tuscan aquifer investigation.
So I'm going to go back to this next slide, so we can just kind of talk about these again, if that works for you all. So this was sort of the game plan, but if we want to change anything now, this would be a good time to maybe chat about that. I think we did talk about already the instead of this third bullet point, instead of looking at the measuring the first perforation, we talked about measuring maybe all of them or a portion of them. Is there any consensus on what the best approach for that would be?
Well, I was thinking that, you know, you'd start maybe with the top one, as you suggested, and then where you have multiple perforations, go to the bottom, check that one, and see if there's any kind of a difference between that and the top. And if so, you know, then sample in between a time or two.
Okay.
But, you know, just try to do it as efficiently as you can, because even though each measurement maybe only takes 10 minutes, there's a bunch of these out there. So
that sounds like a good plan to me. Okay, and then yep, for at least for 2022, monitoring the RMS well locations for EC and temperature, and then using the previous methods of doing the purging and the pumping for those that are non-completion wells in Wyandotte Creek. Does that sound good to everyone as well?
Yeah, I don't think, you know, how necessary is pH?
You know, it's it's a way to indicate change just as temperature, but it doesn't necessarily give you a sense of
Yeah,
much
I think
else
it's
than
a
pH.
I think it's a standard field measurement, right, that you would take
Mhm.
if you pulled a water sample.
Correct.
In this case, we're not pulling water samples. We're just using
Right.
the probe, which
Right.
has EC and temperature. So that is why it got dropped.
I understand.
And I think the idea could be too that these wells are monitored or could be either by DWR or in the future by the GSA. You know, a full sample could be pulled and run through the lab if needed, or maybe
Right.
on a 5-year basis or something. So that is kind of the thinking behind dropping the pH at this point.
No, I don't have a problem with that. I just want to make sure.
Yeah.
Okay. Well, with that, I'll turn it back over to you, Joe. Thank you, everyone.
Okay, Kelly, thank you very much. w- with our agenda, the next item on here is item number 5, discussion of the potential interbasin coordination projects. And sounds like Christina, you're going to talk about that a little bit.
Yeah. So I'll share my screen here. And this is pretty vague. I wanted to, but we're starting to think about projects to scope up and pursue for funding this coming fall. And so we had talked last time about, you know, talking through with this group a little bit more, maybe just some of the technical projects related to interbasin coordination. And so this is just kind of an introduction to that topic for some, I would say, informal discussion and input from you all. What I wanted to do first was, let me start the slideshow. Can you see that okay? Do you see
Yes.
you just see the map? Okay. I wanted to do just a flyover of conditions in kind of our North Sac Valley region, which the focus is gonna be north of the Sutter Buttes, which is right here, up to about Antelope. And this area or group of subbasins, of course, the 3 that are in Butte subbasin are Vina, Butte, and Wyandotte Creek. And then our neighboring subbasins to the west and south and north. This group was called the North Sac River Corridor. You know, as we share, the Sacramento River comes right down the middle of the valley and is the boundary in many cases of these subbasins on the east side of the valley to the west side of the valley. So first, just a flyover. These are all screenshots from California's Groundwater Live, which Kelly, I think, walked through with us last time. Is a great website and a fun way to poke around through a lot of different data. But this is just a snapshot of, oh, I pulled off the legend. A snapshot of groundwater level conditions. Hold on a second. I'm going to pull this back over just so we can see what these colors mean. So the dark blue is groundwater level conditions that are 0 to 25 feet deep. The light blue is 25 to 100 feet deep, and the orange is 100 to 200 depth to water. So you can see obviously shallower conditions toward the middle of the basin and down here into the, you know, what we've historically called the Butte Basin. And then as you go north and to the sides of the valley, groundwater gets deeper. And you can see that on both sides of the valley, just in general, you know, trends. Ignore on these ones, I cropped them out mostly, but I may need to pull back the legends. Ignore these numbers down here because there's no spatial selection made that makes those numbers really make sense at this point. So this is current groundwater level conditions. And I'm going to pull this back in again so you can see the legend. So dark, this kind of bright red is an all-time low. So these are generally spring 2022 water levels. So that all-time low is in the bright red. You can see where those are occurring. And the dark red is measured groundwater levels that are in kind of the bottom 10 percentile of historical measurements taken in that particular well. So lots of bright red and dark red in our 3 subbasins and in the valley, throughout the valley. On the next one, sorry about this. I obviously didn't fully think through cutting out these legends. So these colors are, this is seasonal groundwater level change. This is a 10-year change. So from spring of 2022 to spring of 2012. And you can see that greater than 25-foot changes over here on the west side, far west side of the valley. Lots of orange, so that's a 5 to 25-foot decline in groundwater level over that 10-year period. And then the yellow, I think, is 0 to 5 foot decline. And then this is a 20-year groundwater level change. So same color scheme, I believe. We'll just make sure. This is for trends in groundwater levels. So sorry, yeah, so this is not change, this is trend. So they did trend analysis on each of these monitoring wells. If it has a bright red color, that's a decreasing trend of 2.5 feet per year on those wells. The orange is 0 to 2.5 feet decreasing trend. So most, of our wells in the Vina Subbasin and a handful in the other two have that kind of trend, 0 to 2.5 feet per year. And then the yellow dots are no trend, generally stable, which we see, right along the Sac River and then down here in the Butte Basin and in most of the Butte Subbasin. And then finally, from kind of a groundwater condition standpoint, here's just a contour map. I didn't find one yet for 2022, so this is 2021. But you can see, when you then contour the elevations of groundwater level measured throughout the valley, what those contours look like. We often talk about, groundwater moving generally toward the Sac River. You can see that these contours tell that story, and then they broaden out and flatten out as you get down here into the Butte Basin, closer down to the Sutter Buttes. And groundwater is generally moving from the northeast to the southwest, and on the west side of the valley, from the west, kind of northwest to the southeast, with the exception of these couple of holes right here, where there is some water moving in that direction, but it's hard to see. This is a 150-foot contour, then 170, and then it goes down again to 140, 130. So there's, a high point right around here. Water's flowing kind of that direction to the west, and then it starts going with the rest of these contours again to the southeast. Okay, so that's a flyover of kind of groundwater level conditions, snapshot mostly based off spring 2022 conditions. Then I switch gears to infrastructure. And so these is just a snapshot of domestic wells. These are based on well completion reports or well logs submitted in all years, which is since 1977. And you can just see this is a density map, basically, right? The darker purple is higher density of domestic wells. And so in our county, a lot in the foothills, right? We know we have foothill communities, and during this drought, we've been aware of that and have seen some dry wells there. Of course, lots in Vina Subbasin as well, and down, in the Gridley, Biggs, that kind of corridor, and in Wyandotte Creek, and then also in our neighboring subbasins, you can see where there's higher densities of domestic wells. And then if we switch gears to irrigation wells, again, this is since 1977, so kind of the record. And you can see where the densities are. These are generally, as we know, Vina, a groundwater dependent subbasin. Our neighbor to the west, both the northern part of the Colusa subbasin and the Corning subbasin have areas of high density irrigation wells also. And so let's just zoom in a little bit, both in space and in time. So this is a look at the last 5 years by county. So I'm just going to take them first, Butte County here. And now these numbers are meaningful. So in Butte County, since 1977, there's 1,400 total well completion reports, and 70 of them in the last 5 years. And you can see what the breakdown of those are in terms of depth. Right, so our wells, even in the last 5 years, actually, this is still the 70-year. It looks like, no, okay, this should add up to 70. So in the last 5 years, the 70 wells is distributed this way. So still generally, less than 400 feet, quite a few of the wells are in that range of depth. And you can see how, when those wells went in over the last 5 years. And then on the map where they are, right? They still tend to be in the Vina Subbasin and to some degree in the Wyandotte Creek area and in the Butte kind of water district area of the Butte subbasin. And then Tehama County to the north, a higher count of wells, 70 in Butte County, 126 in Tehama County. You can see the distribution of well depths. So some deeper wells and kind of steady over the last 5 years of when those wells have gone in. In Glenn County to the west, and I went by county just so there's only 4 and not so many subbasins, but you can also do this by subbasin. You can see where they are, about 137 in the last 5 years. And again, what the distribution of depths are, quite a few in that 200 to 500 range, or really 200 to 700 range. And maybe a little bit of a bump in the last couple of years in terms of the number of wells going in. And then in Colusa County down south of the Sutter Buttes mostly is where the irrigation wells are going in, about 83 wells in the last 5 years. And they tend to be deeper down there. So I thought that might be helpful just to kind of review what's been going on both in our county and in our neighboring counties over the last few years. This website also has the dry well reports, and you can see kind of what that looks like too. As I mentioned, the foothill areas are certainly a concern in Butte County, and that's really driven by drought. And then of course we do have some dry well reports in Vina, north of Chico, and down in Wyandotte Creek as well. And you can see many more dry wells being reported kind of on the west side of the valley and north of us. Okay, so in the groundwater sustainability plans, there was a parallel effort, as these GSPs were being developed in each of the subbasins. There was discussion between staff and consultants working on these programs, and then reported out at each of the advisory committees and board meetings, an effort to try to coordinate GSPs. What we found was that it was a monumental task in itself to get the data and policy in place, in each individual subbasin, let alone to really try to coordinate that in a more regional way. And so what resulted from those information sharing discussions really was this framework document that outlined some of the ways in which these GSAs and subbasins might want to coordinate in the future, both kind of from information sharing and communication and policy, but also, on technical issues. And so this was incorporated in different ways in different GSPs, some more directly in the Vina subbasin. There's in the implementation chapter of the GSP, of the Vina GSP, there's an interbasin coordination section that outlines, and I'll just highlight it again, outlines kind of what the Vina subbasin intends to do and how they intend to coordinate with their neighbors. Other GSPs in the region essentially included the framework document as an appendix and referenced it, that they intend to continue interbasin coordination and reference this framework document with kind of details to come. Okay, so one of the reasons we're also kind of gearing up to frame up some of these things with a little bit more detail is we anticipate a Sigma grant program funding opportunity close to the end of the year. DWR is administering this grant. It's an implementation grant, but it can be money for both projects, kind of implementation projects of GSPs or planning dollars. So, updates to modeling, updates to the GSPs, filling data gaps, monitoring, all of that kind of activity as well. And we anticipate there have been 2 rounds. They've already awarded funding to critically overdrafted subbasins, and that was a different process. Now our subbasins are eligible for round 2, and that's a competitive process. And we expect it to open in late 2022, although the timing is still a bit uncertain. We do have to have 1 application per subbasin, but there can be multiple projects included in a single application. So certainly coordination is needed, within a subbasin, particularly where there's more than 1 GSA, right? Those GSAs have to work together to submit 1 application for funding. So that's gotten us thinking a bit more strategically and specifically about, you know, what these GSPs say they're going to do as we move into implementation, and interbasin coordination is part of that. So as an example, this is the VINA GSP. These are kind of the 5 pillars, they were called, in that interbasin framework document. And it includes information sharing, which is really about establishing lines of communication and sharing information. And then these 2 and 3, which are a little bit more technically, have technical basis, I think, and we'll talk about them a little bit more: conducting joint analysis and evaluation of GSPs, and coordination of mutually beneficial activities. And then 4, coordinated communication and outreach kind of throughout the valley regarding SIGMA issues and topics and concerns. And then 5, issue resolution process. So I think where we want to focus at this point as the TAC is just thinking about these kind of number 2 and 3 from the technical viewpoint, and kind of thoughts and inputs that you might have as technical folks on what how these things should be framed up more specifically as we think about pursuing funding. So number 2 there was conducting joint analysis and evaluation of GSPs. And a version of this was also included in the Wyandotte Creek Subbasin GSP. But this essentially says that in the near term, the VINA Subbasin intends to pursue grant funding to collaboratively work with its neighboring subbasins in this North Sac River Corridor group to hire a consultant to do this work, and to really evaluate and compare the contents of the GSPs. We kind of set out initially to do this under GSP development, but like I said, there wasn't the time or the resources to do that. So now that each of our subbasins have adopted a GSP, there's an opportunity to look at the monitoring networks that are in those, to look at the SMC criteria that are in those, to look at the modeling that was used as the basis for those GSPs, and understand what the similarities and differences are, identify those significant differences and potential issues of concern, and then figure out, go from there, at least establish the technical basis of what these GSPs share or where there may be concerning differences. So that was described as a potential project or effort. And then number 3 is this idea of coordinating on mutually beneficial activities, and that the VINA Subbasin will work collaboratively, again, with the subbasins in this North Sac River Corridor area to identify items in our GSPs that are ripe for coordinated project or pursuit of funding as either projects and management actions or data gaps. And so when we think about this, it could be things like better understanding interbasin flows between the subbasins, how those were modeled differently, or how they can be monitored by existing monitoring networks, or what additional monitoring might be needed, that kind of thing. So that's the VINA GSP, and just kind of reminding ourselves what was said in those GSPs in terms of what kind of coordination might occur in the future. And then in the Butte Subbasin GSP, they were less specific in terms of pulling content of that framework directly into the GSP itself. It references the framework document and it is included as an appendix. But a couple things I wanted to highlight there is that it does describe creating this Sutter Butte's water quality interbasin working group. And you may recall, and this hooks back to the water quality conversation, in the Butte Subbasin, there's this area down here by the Sutter Buttes where there is shallower, high salinity water and other constituents potentially of concern as well because of the geology in that area. And so the GSP describes putting together kind of this interbasin working group that would include Butte Subbasin, Sutter Subbasin, Calusa Subbasin to kind of appropriately set up monitoring in that area, and SMCs as needed, or make adjustments to what's in the GSP. So that's what that's about. I think there hasn't been any kind of movement yet on putting that interbasin working group together or anything like that, but that's something that we'll want to keep an eye on and think about, perhaps if there's a member of the TAC that wants to participate in that or what that might look like in the future. So just kind of putting a pin in that, at some point there will start to be some movement on that topic. Otherwise, there's also a description in the Butte Subbasin about a GSP about the Butte Basin groundwater model update, and that is actually, I think, some version of that intent is in all three of the plans. This is a lot of language, but you may recall us discussing about last summer as these GSPs were going together and what kind of refinements, we would recommend be made to the Butte Basin groundwater model. And so that's where these bullet points came from, refining how interbasin flows are addressed, stream aquifer interactions, how the geology is represented and using AEM to update that, and some other things there. So I think one of the questions that was brought up when I was starting to talk about potentially projects and work to go after grant funding for was this Butte Basin groundwater model update. And the question was, is that something that we'd want to do, or do we need more regional modeling? And so I thought I would just kind of tee that up for this group to begin to kick around also. And really the question there is, what questions do we anticipate trying to answer as we move into kind of GSP implementation? And we asked this question initially, right, when we were heading into GSP development, but now we're in a new phase. So is the Butte Basin groundwater model the appropriate tool? Do we continue to refine and update that and exercise it in terms of using it to evaluate projects and management actions and understand, dynamics in the Vina subbasin or the Butte subbasin or the Wyandotte Creek subbasin, or is a more regional model appropriate, and for which questions and at what times are. So that's a question we've kicked around in the past, and I think we'll continue to discuss that. So I just wanted to raise it again. So with that, just kind of summarizing a few things here before I just open it up to you all to share thoughts or discussion items on these topics. One of the potential projects, again, is this kind of evaluation of GSPs. And is that something, I think that's something that the Vina subbasin certainly is interested in pursuing, and collaboratively with neighbors, whether that's actually a shared project that we each pursue funding for and do in a really coordinated way, or whether that's something that the Vina subbasin kind of leads and then hopefully just, partners with neighbors on. And then some of these other things, these mutually beneficial activities, what might those include? A couple on the list that have been talked about is just generally addressing data gaps. And those could include, topics like monitoring and modeling related to characterizing stream depletions. That's that undesirable result number 6. Or monitoring and assessing groundwater dependent ecosystems and that topic. But, just as I've talked through these things, based on what you're aware of in these subbasins, what might be other mutually beneficial activities that we should think about really coordinating with our neighbors on. So with that, I'm just gonna leave these couple questions and open it up for questions or discussion.
I think this is a lot. This is incredible amount of opportunity. I mean, you've covered a huge amount of ground here. What comes to mind initially is some of the shared mutually beneficial activities, such as monitoring the water table and doing the real shallow groundwater, and especially on the Vina Butte, we don't really have a good network for the shallow zones. And I think I don't know if that's the case for the other subbasins, but I think that would be one of them. And as far as the updating, well, actually go back as far as that first activity. So in a slide before, number 1, potential project evaluation of GSPs. You mentioned Vina subbasin is interested in this thing, looking at with their neighbors. I'm initially, my first thought was great. They can reconcile their differences between, especially these MTs and these MOs being so different between Vina and the others. And then I'm thinking, maybe Vina is going to bring everybody else's MTs down with them. I don't know. But as far as that, I think it would be excellent for the GSPs to be looked at in detail when comparing buttes to Vinas to Calusas and Cornings. I think that would be very worthwhile, just to look at how different they have done things from a fundamental standpoint. But I do think what you know, my second reaction was, wow, let's do all of these things because they're all very important. But you're probably looking for, you know, what's most important to go after, which is a tough one. But
Yeah.
I would say you know, connecting the GSPs between each other, I'd say the mutual beneficial activities like shallow groundwater, but the groundwater dependent ecosystems, I think is something that's become that needs to be looked at more between the two, because that and then the effect of deep pumping and what that will do interbasin wise, especially as you have shown, there's a lot more deep wells in the west side of the river than there are in the deep, especially recently. What are the effects of that between the two, and targeting that question. But you know, coming back, it's just like it's all needs to be addressed. But and you're covering a lot of really good ground here. So yeah, I can just keep going on and on, but I'll let other big people go. Uh-oh, was my mic off the whole
No,
time?
you're good. No, we heard you.
Anybody there?
We're here. No, that was all good. And I'm not necessarily looking for you to kind of pare down and give me your top two. I'm just kind of looking for putting more meat on the bones and any thoughts you have around these things. So that's all good.
I wanted to add something. I think and Todd brings up a good point, like there's a lot of things here, and I think it's important as we move forward and as the GSAs move forward is to really differentiate what the GSAs are going to be doing and what we're contributing to that, because there's a county role. And so the GSAs will be doing a lot of things like addressing data gaps from the GSPs, which will cover some of these things like interconnected streams, GDEs and things like that. And so really remembering, and I know it's hard for us as a department and staff, is which hat we're wearing at which time, but making sure that we kind of each stay in our lane, and then the department will serve as kind of the collaborator to allow some of that crossover. But because this department isn't going to be doing all of this. Some of it will be done by the GSAs. And right now, yes, we're serving as kind of that staff and administrator, but hopefully a year from now, we'll be able to differentiate and have a different face with the GSAs than just this department. So I think that's important to just keep in mind.
Mm-hmm.
You have a question from one of the attendees as well.
Jim Brobeck.
Hi. In the groundwater sustainability plan regulations, the Department of Water Resources recognizes that groundwater conditions in one basin may be affected by groundwater management practices and adjacent hydraulically connected basins. For instance, when Glen Cluse Irrigation District conducted the 2008 Stony Creek Fan Aquifer Performance Test Project using deep wells in the Hamilton City area, isotope analysis indicated recharge came from the eastern foothills above the Vina subbasin. The David's Engineering advised us that the ultimate effects of pumping in one basin can occur significantly after pumping starts or even after pumping has ceased. And the timescales involved to aquifer responses can persist for decades, which makes it difficult to associate cause with effect. So modeling and monitoring must account for this lag in impacts. Regional models are preferred to coordinate between these GSAs, the close ones. It's my understanding that as of 2016, DWR was developing a new model for the Sacramento Valley calling it the Sacramento Valley Simulation Model, but it was not complete when our GSPs were drafted. It's also my understanding that it was being developed to evaluate water transfer projects in the Sacramento Valley, so it might not capture conditions that result from supplemental groundwater pumping, crop pattern shifts, and other regional stressors in the shared aquifer. The interbasin agreements that Article 8 of the GSP regulations describe must include an estimate of groundwater flow across basin boundaries using consistent and coordinated data, methods, and assumptions. They're optional, but it's likely the department will view our submitted GSPs more favorably as complete if we have such models and monitoring protocols in place. I agree that it's very important to understand the shallow aquifer conditions, both baseline and as they develop. And I think it's equally important and even a prerequisite to having a really rational GSP that we understand these cross-basin dynamics. So developing a model that can be agreed upon regionally and that preferably, in my opinion, in the upgradient portions of the aquifer system, of the Tuscan aquifer system over on this side of the valley, that we have considerable input into is a real priority as we develop. The wells that have been installed in the Glenclusa Irrigation District footprint during the past 5 years is truly alarming and may have very long-lasting effects. So the sooner we get modeling and monitoring in place to understand these cross-basin flows, the more likely it is we'll be able to achieve our goals in our groundwater sustainability plans, I might say, in the Vina and Butte subbasins. That's my comment. Thanks for taking it today.
Looks like Richard. Yeah, go ahead.
Richard Harriman.
Passing the intelligence test. Can you hear me all right?
Yes, we hear you.
Hi, I really appreciated the comments that were made by Professor Green when he was tying together the various straws and strings of what we're trying to do here. And I'd like to ask a question to Debbie as to whether or not DWR has already started on trying to develop some sort of long-term carrying capacity analysis by drawing together some of the findings that you're seeing from the GSPs. And I'd like to refine that question a little bit more to say it this way. I understand that the Sigma process that we've been discussing today will address that incrementally over time. My concern is unless we get moving forward, maybe with a little bit more jet-assisted financial power from the state, that we may overshoot what the carrying capacity will be, especially if we have a long-term drought scenario. So I want to thank the TAC. I'm so impressed with the level of discussion, and I'm new to this particular agency. But I would appreciate if Debbie might be able to comment on that with specific reference to what DWR may have learned from looking at the San Joaquin Valley and its subsidence and clear overshooting for carrying capacity.
Could you refine your question just a little bit? I think you asked me. Let me repeat it and see if I understood correctly. But you're asking me if at DWR have undertaken say a valley-wide effort at evaluating carrying capacity / sustainable yield for the groundwater conditions. Is that what you're asking me?
I have to be recognized. Can I be recognized? Are you hearing me?
Yeah, go ahead. Go ahead, Richard. Clarify.
Thank you, Christina. Debbie, thank you for calling the question, which was starting backwards from my final question. If I'm interested in, as I sit on the Butte Water Commission here and been following water activities in the Sacramento and San Joaquin Valley for over 50 years. So I wondered whether or not DWR has looked at what has happened in the San Joaquin Valley to see whether or not there were some things that have stood out in the review of their GSPs and the shortcomings with respect to trying to get a pretty, how do I want to say it, a working hypothesis as to what the sustainable yield is in the Sacramento Valley, or particularly in our basins that we're related to.
Okay, I think I understand how to answer that. So, I mean, I think Sigma in itself, although it's not DWR's effort, it's just DWR's task to implement, is the comprehensive evaluation of that, and that the actual numerical estimation of basin sustainable yield. I mean, I think honestly, technically, that's too complicated and too regional, small area, not wide region, of a question to have a specific number for the Sac Valley. So I am not aware of any effort from DWR at this point to come up with a number for the Sacramento Valley as far as sustainable yield goes. That's what's happening basically in the GSPs on a basin by basin effort. And I hope, and this might be a little optimistic, but I hope that as implementation of that goes on and evaluation of, the various basins sustainable yields is evaluated against the data over the next 10 to 20 years, then a number will, a legitimate number, not just a modeling guess, will start to materialize, and we'll really have an excellent understanding of what can happen and can't happen in various areas, and what impacts we would expect to see. I'm not sure that answered your question, but
May I respond? Hello?
I think you can respond, but
I'm not getting.
Are you I was muted. Go ahead, Richard.
Okay, thank you. Debbie, no, that was good. And I guess the way I was trying to break it down analytically, hopefully be some help to the TAC, and I definitely will attend future meetings. DWR has a number of, within ranges, the amount of surface water supply that's provided through the various DWR and CVP facilities. So we know a surface water number. And then I wondered whether or not there's a working number that has been looked at or is being teased out as you're reviewing these documents, or whether that really is, if it's going to be a while, are you thinking 5 years? Just trying to think. The reason I'm asking the question, Debbie, is to try to figure out which projects or management activities can be most effective in the short term to addressing the potential shortages that we're expecting.
okay, so I can say with confidence that there is not a number that's being used as a guideline for during our GSP evaluation. So we don't have an internal number that we're looking for the combination of the GSPs to meet. We're looking at each plan, well, I say individually, but understanding that when we come to the Butte County and the basins in Butte County, that they're, it's not completely independent, but we don't have one. And I mean, I also am not aware internally of a discussion or an understanding that DWR has, although I would certainly, our our office would be happy to be part of that conversation with the local GSAs if we could be of technical assistance. But I think honestly, the GSAs have better information and understanding for what the key projects are that need to be implemented in order for the maximum gain to be seen in the short term.
Yeah, and I would just add to that. I mean, I think too, we're just beginning to see the huge value in the annual reports that each subbasin has to submit, by April 1. And it's a quantification of estimate of groundwater demands by sector and surface water supplied by sector. So Sigma has really kind of upped the data production on some of these things and driving it out of the locals, which I think is where you can get more detail. So that's a good thing.
Yeah, I have a comment going alongside the concerns that that Jim and Richard both brought up, and that Todd mentioned earlier, and that is these regionally coordinated efforts. And certainly one of the things that would seem to me to be a top priority for Butte County is to make sure that our efforts to make our groundwater sustainable are not compromised by any of the adjacent basins that might have pumping occurring much deeper, particularly west of us in Glenn County, where your summary, Christina, indicated they'd been putting wells in that were 600 or 700 feet deep. And if that, water use that they're pulling on over there, recognizing that the west side is always going to be in a rain shadow from the coast range, and is always going to be drier, and is always going to be under more pressure. It will be really important for those of us on the east side of the Sacramento River to make sure that our groundwater levels are not compromised by groundwater levels on the west side that undoubtedly are going to be required to go lower and lower over time. And so over this planning horizon up to 2030 or whatever the year is, we've got to make sure that west side is not going to compromise our ability to sustain the levels that we need to have in the Tuscan aquifer on our side of the river. So I think looking at that coordination between those basins has got to be one of our top priorities going forward.
Yeah, that makes sense. And we've heard, it's good to hear that. I think we've heard that from, the board of supervisor level, GSA boards, public. So there's broad support and shared, that is a shared priority, I think. So as we pull together and kind of add details to what these projects might be and thinking about going after funding, I think we can expect at least Butte County subbasins to prioritize that as a project to build on the information we already have, but really fill in some of the gaps that we have to address that concern.
Yeah, this is Mike Crump. Can you go over the timing of this? Because again, I think these subbasins you mentioned are going to be eligible for these grants too. And when do we know what they're thinking of? And so we can then consider, either filling in the gaps or doing something more regional, such as Joe, mentioned. I think that is a really high priority for us. But what is the timing, for this decision?
Yeah, great question. So we're just starting to have conversations at the GSA level about this Sigma grant funding opportunity. And the process that we've kind of outlined is that, each of the GSPs have a list of projects, management actions, and then implementation activities. And interbasin coordination is one of those implementation activities. And so they're going to have to weigh and kind of prioritize and choose a package of things that they want to submit funding for. And so that for example, in the Vina Subbasin, the Vina Stakeholder Advisory Committee actually meets next week. And we're going to do kind of a two-phase process where like I mentioned, these things have some information in the GSP, you know, in terms of what a joint analysis looks like. It's right here, right? But for this to actually be a project, we really need this. What's the scope of work? What's the budget? What's the schedule for this type of effort? And so we're going to be getting recommendations and discussion from the advisory committees, and then ultimately direction from the GSA boards on what projects to develop details and scope budget schedules for. And then we'll go do that work over the next couple of months and then bring that list of projects back. And then there can be a discussion around which of those to actually include in the grant application and pursue funding for. So as of now, and Debbie, you can throw in if you know more information about the timing, we kind of anticipate the grant application to be due or submitted toward the end of the year. So this is really over the next 5 or 6 months that we would be scoping these out more. And so what we anticipate is kind of some working groups that would be project or topic specific to weigh in on the scope and of some of these things. So I think we may have another TAC meeting to talk about it if we anticipate it being kind of a Butte County project. But if it stays in the GSA realm, then I think we'll just try to keep you as TAC members informed that those, you know, working groups are happening if it's a topic related to this. And you can choose to participate as a member of the public if you'd like, and kind of bring your perspective and expertise to the conversation in that way.
Okay, thank you, Christina. Our time is getting short here as far as our committee's plan, and you have some departmental updates that you wanted to highlight, I guess. Cami, were you going to do that, or who was going to cover that?
I think it's going to be a combination of us. I thought maybe we would start with the drought update. We will be providing a drought update to the Board of Supervisors, and there's a couple of things on that list of for that update. I thought Kelly could provide just a quick overview of some of the well information, as she has already touched on today, but there's some additional information that she can just cover real quick. Kelly?
Sure thing. Yep, and this is all going to be updated with new numbers to the Board of Supervisors on July 26th also. But yet we're still in a drought, as everyone knows. Environmental health is tracking well permits that come in. There's a question that they asking whether or not the permit application, asking the permittee whether or not they are applying for a new well permit due to the drought. And they're indicating that the data does not indicate that the majority of dry wells are occurring due to that. In the 2021 water year, there were 121 small diameter well permits and 24 large well diameter permits. And of those that did indicate that they are because of dry wells, most of those are occurring in Chico with an average dry well depth of 110 feet. We're also tracking the wells which are subject to the N-7-22 executive order, which relates to the GSAs and the GSPs. And so far, as of last week, we've received 18, or they've received 18 that were subject to that executive order, 11 in Butte. So most of them in the Butte subbasin, 3 in the Vina subbasin, and 4 in the Wyandotte Creek subbasin. They're also working with 2 schools, or I'm sorry, 1 school, at least Spring Valley School near Pence Road, that's showing signs of slow to no water at some of their wells, and also Almond Grove Well, which is being investigated for cause of no water, but that might just be electrical issues. There is a DWR dry well reporting form that we've talked about. As of last week, there were 23 reports of dry wells in Butte County. And while it is voluntary to indicate what your well depth is in those reports, most people don't do that. But of those who did, 7 out of 9 had wells that were less than or equal to 270 feet. And 2 of them were a little bit deeper, being 430 and 475 down in the Oroville area. Of those 23 reports, 9 were in Oroville, 5 were in Chico, 2 in Forest Ranch, 2 in Palermo, and then 1 in each of the following communities of Bangor, Durham, Pence, Cohasset, and Butte Valley. Let's see. Excuse me. So when we do get the dry reports, the dry well reports, we're now linked up to get those and get the contact information for those folks. So I am calling everyone who has filled out those reports and getting them directed to appropriate resources, whether or not that's sending them a link to Butte County Office of Emergency Management's new drought assistance programs, or whether or not, you know, we're getting them over to be able to find their WCRs, their well completion reports, just getting them to the right resources. So currently, the Office of Emergency Management was awarded a $1.16 million grant from DWR through the Small Community Drought Relief Program. So those funds are being basically delivered out in 2 phases. Phase 1 is for those who do have storage, like water storage tanks at their house. This program is providing hauled water to residents. And the second phase will be to install temporary water storage tanks for households who do not have storage tanks. Those will be 2,500 gallon tanks. And to date, 96 people in Butte County have applied to that. So we're also doing a crosswalk between those who have filled out the OEM application and the dry well reports to get a better understanding of what the real need is and what the impacts are here in the county. As you may or may not know, the drought impact analysis study was completed in May and a public webinar was held in June. The information on that was recorded and it's on our website if you'd like to check that out. It was also, we got recommendations from the Drought Task Force and the Water Commission regarding that study, and those will be presented also to the Board of Supervisors on July 26th. And in addition to that, the Drought Task Force and what we're calling the internal team here is updating the website. So on the main page of Butte County, you can find a drought link, but it's buttecounty.net/drought. So that's been updated to have all the information about the water hauling program that I just spoke about, links to our new updated websites regarding water conditions, water conservation, and other resources for private well owners, and a whole slew of good information. So if you have any problems or questions or any needs to access any of that information, you can feel free to reach out to me directly.
Okay, thank you, Kelly. Debbie has a question.
Hey, Kelly, I'm sorry. I missed how you guys were getting the dry well reports. Could you repeat that again?
Oh yeah, no problem. We've been working with Bill. The counties now have, as a point of contact, have the ability to get notifications when the dry well reports are submitted for that county. And so we have access to basically reach out to those residents and get them to the right resources that they need.
Oh, that's great news. Thank you.
Mm-hmm.
Okay, very good. Other updates here from the department?
Yes, I also thought I would add, thanks Kelly for covering all that. I just wanted to add a couple more things about the drought impact analysis study. As Kelly said, that there's some recommendations that are going before the Board of Supervisors on the 26th. And among those recommendations and primary to it is updating the drought hazardous hazards and preparation plan, the drought plan. And that would be contingent on funding. So we'll be pursuing some money to do that, hopefully, if that's what the board wants us to do. I'll say that while we have a drought plan, there is some recent legislation from last September that we'll need to update the plan to include more information about domestic wells and small water systems, water supply systems. So hopefully we'll be doing that. Also, as part of some of the recommendations from the drought impact analysis study would be to have some screening tools and a risk assessment process and some response metrics that trigger different actions during drought. So those are some of the recommendations that will be going before the board. With regard to other updates, there's SGMA updates, and Christina covered a lot of them, especially as part of the grant application process and inter-basin coordination. Just as a side note, so one of the big things for the GSAs and implementing the GSPs has been, one of the challenges has been funding. So the GSAs haven't pursued a long-term funding option. So how we were going to do some of the implementation and administer the GSAs has been a question over the last few months. And so this department included as part of its budget request for the next fiscal year, a kind of a one-time budget request for funds to administer the 3 GSAs. And so the board at their June 28th meeting approved the recommended budget with that one-time funding. So it will help this department, the one-time funding covers some extra help, and as well as some funds for professional and technical consultants to assist staff. And that would be for 3 primary tasks. And one is the SGMA grant program, preparing annual reports, and then long-term financing options for the GSAs to consider moving forward. So for the next year, those are kind of the 3 primary tasks that we'll be focusing on as a department with those funds. And so, yeah, with regard to SGMA and the GSAs, there's nothing really additional to report on those, unless you guys can think of something that I've forgotten. So I think that's it with regard to those 2 items on the agenda.
Okay, thank you, Cami. Appreciate that. That kind of brings us to our next agenda item, which is TAC members wishing to address any items that were not on our agenda. Is there anything that Richard, Mike, Debbie, Todd want to bring up or ask about or suggest we look at the next time we meet?
Nothing here, Joe, for Mike.
Okay. All right. Okay, well, I'm sure we'll have plenty to talk about next time. We do have our next meeting scheduled for August 22nd at 1 p.m. The last item on the agenda before we get to that future meeting is public comment. If there's anyone present still that would like to address the Technical Advisory Committee on any item that wasn't on today's agenda, I would like to welcome you to do that at this time and at least give us something to think about. So anybody out there that might still have something they want to share with us?
We have no hands raised.
Okay. All right. Well, with that in mind, it looks like we have managed to work our way through the agenda. Sorry that we ran over a little bit for everybody, but I think we had some good discussions today, and we've got a lot of things to think about. So thank you all for being here. I appreciate all of those of you from the public that took the time to join us, and certainly all of those on the committee today that showed up and allowed us to have a quorum and continue to move on with our business. So thank you all for being here. And I think with that, it concludes this meeting of the TAC.